Hi everyone, I'm Fergal. I've been looking into passkeys and signing and how we can sign transactions on Algorand using passkeys and only passkeys. I don't have a presentation and I have a terrible UI. Also, I'll give a spoiler now, it doesn't work yet. But anyway, what it should do is something like this. So you create a passkey. For those who don't know, passkey looks something like this. So it's attached, it's built into your browsers and your operating system on mobile devices. It uses your biometrics when it can. It generates something, and that something includes a public key, and that public key has an X and a Y. The private key for that is not accessible to any web app or any API on your computer, so it's securely stored. But the public key is available. And these public keys correspond to a ECDSA public key. And so we can, and when you do something with passkeys, so when you're challenging the user to do something, you provide them with a challenge and then you get them to authenticate. And usually that challenge is completely random. And after they do that, you get back something like this. So some garbage, basically. But there's four pieces. One is client data JSON, one is authenticated JSON, and then you have the signature, which is RNS. And somewhere inside this client data JSON, which is clearly not JSON, is the challenge that you originally gave. And then the authenticator has some additional information. And the signature is done over this whole, the concatenation and the hashing of those are the two things. So what I figured was that we can, in a logic sig, we can verify this stuff. So the X and the Y that we get when we create the passkey with the public key, we put them into a logic sig. Normally these would be template variables, they're hard-coded for the moment. And then the other stuff, the authenticator bytes, the client data, and the signature bits, we pass them as arguments to the logic sig. And then we decode them, and thankfully on the AVM we have opcodes to do exactly this. So JSON-ref, base64 decode, these are built into the AVM, and they're exactly for this scenario. They're not for normal JSON stuff, but they are for this. So you get the challenge out, and then you confirm that the challenge is exactly equal, that's not going to be there, is exactly equal to the group ID. So the thing that you signed is the group ID of this transaction and the other transactions in the group. So you know it's for this and it's for nothing else, and it can't be reused. So then you can concatenate the authenticator data bytes and the hash of the client data bytes, and then you get a data, and then you hash that again, and that's all grand because this is a logic 6, so this is cheap enough. And then you pass that into ECDSA verify, and you basically verify that the data hash is equal to, the data hash for this with this public key and with the signature is all correct. And then you attach that to a transaction, and you hope that it works. And so basically we pass this into our sign method, and then our sign method takes the logic sig, which is the bytes of that contract that I just showed you, and passes in the data that we had. And then we pass that to our passkey sign, which basically does the challenge to the user, and then gets the stuff and mashes it all together, and then submits the transaction to the chain. And then we do that. So we sign a transaction and we hit the button, and then we get back our ORNRS and our stuff. And then if we go to our developer tools, we see that it didn't actually work. It nearly works. It should work. It's just a real pain in the ass to debug this kind of stuff. So it's very, very close. It is theoretically possible. It definitely can work. It works in some other environments. It just doesn't work quite yet in the browser. Also, you might be concerned about using ECDSA, and in the future you can use Edwards. Some browsers, some devices support Edwards, not all of them, so currently just using ECDSA. But yeah, the Algorand virtual machine is awesome because it has verification opcodes for all of this stuff. That's it.